So guys, thank you so much. Huge respect goes out to all of you for making it here. Thank you for joining our experiment. Just a couple of words about the event itself. So quite a lot of effort and willpower it took to do something differently. That's always a challenge. So I'm urging and encouraging you to please do it your way. Don't listen, don't look back. Don't listen to other naysayers. Today, me and the guys from Cyber Congress, we wanted to show you and finally share some specific results, something concrete, what we've been at for the past years, what we've been doing for the past several years. Me and Valera will talk about chain gear. I'll be talking about CyberD. Valer will be talking about chain gear. Sergey will talk about the Web3 browser. These are the three main directions around which most of our efforts is happening. So currently, there's probably around 100 blockchains, unique operation, definitely not fewer than those, more than those. Possibly around 10,000 tokens listed at various exchanges, but the operational apps, well, they're simply not there in those quantities. So the issues right now, currently in Ethereum, possibly there's only like 3 apps. I'm not just talking about the apps which are based on smart contracts, which run on SCs. Applications, apps that run with proper economic logic, where blockchain is really required. Talking about decentralized Dragonerium. Great guys, you're so cool. So that is the ultimate conclusion. There was a lot of hype. There was a fall recently. It was quite predictable because nothing works properly. The question is, how comes? Why doesn't it? Possibly that's because there is a lack of proper tools for the developer on the one hand to go forward and code some application. So on the one hand, you need to make sure that the developer is able to do something and get something done, code something. On the other hand, we want the user to not have to work the magic, dance around with some magical wizard tools to adapt the learning curve so it becomes more smooth. And ultimately, we started talking about what's missing in the industry. So we've been thinking about how to simplify this curve, how to make it better, how to optimize it. Considering the network's history, it started proper developing. First, the databases came around. They helped provide a decent level of abstraction for the developers to prototype faster, to develop the code apps faster. Then browsing came around, and then there was searching. These are the 3 components which are essential at this point. They're essential for web. And looking at this, looking around at this, seeing as how there's billions and billions of dollars circulating in the industry, well, nobody's actually doing anything meaningful. Pretty much no one. Browser developers, all they do essentially is they kind of try to put bells and whistles on Web 2.0. Databases, well, the fact that you can provide a sort of comfortable level of abstraction to avoid writing up a whole bunch of unneeded code, redundant codes for every application you write. Well, nobody's thinking about that. Searching, a whole lot difference to it. Well, there's got to be like 5 blockchains which are used for that. Well, the transaction hash, well, good luck finding that. Good luck pulling out the data on transactions. The search is pretty primitive. Again, nobody's making a decent effort in this regard, or trying to at least. So let me tell you about search more. The repository is called CyberD. The idea started like about 2 years ago. I wrote a paper. I was based on IPFS. I was quite inspired by that. And then gradually the team was being assembled. Half a year later, Valera came on board. The team started to take shape, and possibly around February, we completely reconsidered, reworked the project. What I'm about to show you right now are the results of this year's activities, operations. And essentially the primary objective is to reach the genesis of network, to get there. This is going to be a network, a blockchain network, that is going to be efficient enough, an efficient indexer and search engine. So essentially, why would we need 3.0? Well, we need the new search. We can come up with a whole bunch of answers, but the most reasonable, the most logical one, yeah, we can. We can. It's not challenging. So we need to get down to that. So what did we start from? What did we start building the engine from? Consensus computing based on search. Well, what is a knowledge graph? We defined that first. And ultimately, we reached this stage. We're building it on top of IPFS at this point. But at the core, there are identifiers, the content, which are connected, which are interconnected. So it's kind of a directed graph, or targeted graph, with identifiers linked with content. And they ultimately build a network. So what do you need to know about content identifiers, CID? So show of hands who use IPFS. Well, you know how this QM hash looks like. This is the content identifier, essentially. What is conceptually important to understand in this context is that this CID is essentially a link. It's de facto a link. It's a link that we are used to in conventional web. I've put this on my screen here. It's just Cosmos white paper link, and that one gets you to exactly the same location. This is the Web 3.0 link. You need to understand that for us to proceed. What is also important in the context of decentralized searches? The agents generate the knowledge graph. It's not Google, it's not Vasa, it's not Petit, it's not Alice and Bob. It's us that generate this knowledge graph. It's user generated. Another important concept, well, I'm just giving you a nutshell of the theory, the most important principles to understand. Next, what we need to understand is the fundamental difference between the hyperlink and the cyberlink. That's the name we came up with for it. So the hyperlink is pretty simple. You know that the link itself, the hyperlink is hiding some chunk of content behind it. Hyperlink. Cyberlink comes as two interlinked links. So you summon the first one, you request the first one, you reach the second one. The difference is the link itself is a piece of context for cyberlink. Hyperlink, well, it's different. Cyberlink is two linked links. Next up, it's very important to understand how we're proceeding forward in building our consensus computing. It's a very important initial assumption that web agents, they make these cyberlinks relevant for themselves, not for Alice, not for Bobo, Vasya, or Petya. They do it for themselves. And this knowledge graph is building on web agents linking cyberlinks relevant to themselves. As a total sum, this can generate something more than that. Then we're switching to link chain. What is that concept? It's a bunch of links. It's a chain of links, as the name suggests. If we take this hyperlink and we transform it into a transaction, and we will get an understanding about link chain. A link chain is a transaction that contains one or more cyberlinks. And also it contains a public key and the signature of someone who is doing this linking or relinking. Next assumption. We are venturing deeper, we are venturing forth, trying to wrap our heads around the meaning of those CIDs in our knowledge graph. It's very important for us to assume that every public key, every pub key that gets submitted by link chains, it has a certain reputation score attached to it, which is kind of projected on every link chain. And ultimately, we have a weighted knowledge graph. It's targeted, it's weighted directed between the content identifiers. Now, the next important bit is this per se is enough for us to use the cyberlinks and to answer, respond, and deliver results for any query. This is the ultimate difference between Web 2.0 and Web 3.0 approach. The link itself in Web 2.0 does not guarantee you anything, does not guarantee you content delivery. It can merely point it to that content. In this case, Web 3.0 can make it happen in a peer-to-peer network. The search engine does not have to know anything about this chunk of content. So this weighted graph will be enough. It will be sufficient to toss a cyberlink into a search engine, and then the ranking of the results will be in the feed, in the search feed. So this is a proof of relevance of some sort. If we were to compute this relevance using any abstract consensus computer, we will reach this stage, which is called relevance machine. This is a concept. A relevance machine, an RM, is an abstract machine that borrows this knowledge graph, or relies on this knowledge graph, and converts it from one status to another, from past to current. Essentially, it's not changing anything about the links. It's only changing the weighting. An important property of this relevance machine is that for that machine to stay useful, you don't need to know the history of the formation of this relevance machine. We only care about the current state. This is very important to understand, to make a search consensus computer very efficient and performing. Because in case of blockchain, we're talking about tokens, about double spending, prevention thereof, about balance history. RM does not have any balance. It only has rankings, and they're not non-transferable, traditionally at least. And that's it. This is the entire theoretic basis. This is the theory base that is enough to put you with some understanding as to how our search engine operates. That's enough for you to have a feeling of something smart and finite and a beautiful picture. Yeah, a beautiful picture at that. I wanted to highlight that as well. Then there are questions. Many questions pop up as to, like, guys, what is your consensus algorithm? We're no big fans of reinventing the bicycles, or rediscovering Americas. There's quite a lot of those going around. Quite a lot of people, quite a lot of developers are doing just that. Well, for you to understand, I maybe have 12.5 projects in my portfolio alone with a unique consensus algorithm, like built from scratch, implementations and consensus algorithm. That's cool and awesome, but if you want to put together something operational, and you know that a Tendermint is like maybe 5 years of input, of contribution from all the guys in there. And looking at all that, having analyzed all that, having analyzed the readiness, the preparedness, some theoretical bits, we approached Tendermint. There's quite a bunch of reasons for that. I've listed them here. It's more or less adequate performance. The speed can be tweaked out, given proper decentralization. So there are safety guarantees as well. There are certain guarantees. The white paper was published in the summer, the formal one. It's a very cool economics, which is squeezing every bit of juice and blood from the validators so that liveness and safety are guaranteed. Tendermint is fairly flexible at that because of very good finality. And essentially, we decided to lean on Tendermint. We decided to leverage Tendermint as a solution. Well, I don't believe it to be perfect for our case. Our search engine is supposed to be ultra performance level, but of the things we can take and borrow, we don't need to have the fastest blockchain out there. We need to get an operational search engine out there. This is a very important difference. This needs to be understood. Quite many people forget that the things they create are supposed to be operational, not just lightning fast. We've taken Cosmos SDK. It's not perfect, not in the least perfect. There's bugs, there's malfunctioning things, there are issues. However, this is something that allowed us to put a network together that we can take to testnet. Next question to be answered: which ranking to use? At the dawn of Web 2.0, Linus Ware published a paper like "Let's bring order to web." They were talking about page ranking. However, that is the issue. We started considering which rank we're supposed to use with certain properties in mind. And we ultimately realized that we only want 3 properties. It's supposed to be fast, very easy, unparallelable, or deparallelable. It's supposed to be predictive. So based on it, you gotta have a high degree of probability of prediction of links, of web links in the knowledge graph. And it must be deterministic, so that nodes can validate the calculation of it. And it turned out to be a non-trivial task at that, because there's quite a lot of hype going around a couple of years back. When people from Nebulous said, we're gonna super fucking awesome rank, they put a white paper together and then they sucked at it. Nobody did anything operational. I mean, it's a fact. The consensus computer could not calculate, could not do the math. So they've been trying to put it together. Another year passed by. The core, non-core, another white paper of theirs. But it's not easy, bottom line. Ultimately, we found a Spring Rank bit. Spring Rank is fairly fresh research. Very interesting approach. The guys have been looking at physics, at how it works in physics. So this graph can be represented as a system of springs. And basically, rank is the relaxed status, relaxed condition with minimum energy, where energy is minimized. And we decided to, well, the story behind it is that there's quite a lot of ranks out there. And it's clear when those ranks were being developed, nobody was thinking about, well, it would be nice for it to be calculated, or for it to be executed in a consensus computer. It's a work in progress at this point. We have not ourselves reached this stage. Well, maybe it's several dozens %, but this is what we proceed, right? Okay, so this question comes up. Where are you supposed to take the initial reputation for this knowledge graph? Well, we didn't think too hard. We decided to take the Ethereum blockchain to calculate the Spring Rank for every address in the Ethereum. This will be the genesis of our network. So we kind of take on the balances in our network based on this rank calculation from the existing addresses in Ethereum. What is the analog of this energy stored in the spring when it's tight? Well, the input, the link is essentially an outgoing address. I mean, I'm sending a message to some address. It's a link. The meaning of this link is the balance. Well, by balance, I mean the amount of transfer, the total grand sum of transfer. So these are the two input parameters, and they are sufficient to calculate the ranking for the entire balance. What we do here essentially is we're trying to predict transactions which are going to be made by these addresses. So that's important. We're kind of building a start input for our knowledge graph. We're giving a predicative model that is going to that will be geared towards the development, the growth of knowledge graph. So this is how it goes. Next question: spam protection. How do we protect this KG, this knowledge graph, from spam? Well, limiting the broadband by stake. This is the blunt force method we decided to use initially. Nothing to be invented there. So this linking incentivization is also a very important point. It took me possibly around a year to say no to this. The initial idea behind searching was that we can incentivize the growth of knowledge graph just through the distribution of inflation to those who are submitting some cool links. Right, so you know what I'm getting at, right? No, not going to happen. Not going to happen. There's a fundamental issue still unresolved, which is called egoistic behavior, selfish behavior. And I believe that, I'm still convinced of that, pretty much. Well, it's a very bad idea. This is not going to fly. We totally refused it. So what did we decide alternatively? Was the alternative decision, and this idea seems to be prevailing. It's winning. We don't need to incentivize. We need to motivate the links. What's the difference between it's extrinsic and intrinsic factors? Motivation and incentivization. Internal one is motivation. It's internal. It's inherent. When I myself want to relink without any potential incentive. The idea is we can make the market of predictions based on the relevance of the links. Prediction markets can be created based on link relevance. It's very difficult to predict which link is going to be highly rated in the future, highly ranked in the future. The mechanics can be pretty simple through bonding tokens for every link, for every hash, for every content identifier. Everyone can submit this token for that hash, and the computer can have a very easy time to figure out who bet on which at this specific time, this specific point in time. What is the specific rating? And round after round after round, it will simply redistribute the balance for these bonds. This is the basic mechanics. What about scalability? Everything is fine with scalability. It used to be a very big issue back then, like Google is big. How does it work? Well, I'm thinking of writing up a totally different article, a standalone article on that, because it's a mythical problem. It doesn't exist. It's like a spherical issue in a vacuum. It's probably around 3 gigabytes of links per day. We can process that through a consensus computer. Me and the guys have been thinking about 3 gigabytes. This will enable us. This will give us a terabyte over 3 months' time. And for us to be able to relink all the existing blockchains, all the transactions therein, all the entities, we can relink Wikipedia, we can GitHub, BitTorrent, yes, we will do that. Next, the graph will be growing exponentially. We clearly understand that. There are several ways to scale, to upscale that. There are multiple approaches for vertical, for horizontal. So primarily, it comes next. I'll come back to this later on, to these issues. The principal idea for scaling, this idea that came, it won't get out, won't leave. If you take Cosmos, there is a protocol that is called IBC, interblock communication, IBC protocol. It helps send packages from one tendermint chain to another tendermint chain, meaning that we can prove, essentially, we can take some peak, we can pull up some content and prove its rank to a side chain. And then that side chain can calculate the rank for that individual peak. So a network can establish around that a network of consensus computers, which are very domain specific. Domain specific as in the knowledge domains, various domains of knowledge. This approach is very scalable. And even if the network is key, is fundamental, it will still reach that scalability model. Privacy, it's very challenging bit here. Yeah, it's tough. It's a toughie, because on the one hand, we don't want to let the beast out without the guaranteeing privacy for the users. That's the first and foremost. This is paramount. This is fundamental and non-existent in Google, for example. However, there's also a different side of this coin. Second side to it is that these knowledge methods are expensive as hell. They are crazy expensive for consensus. So that's number one. Number two, it's pretty tough in terms of development. It doesn't come easy. Could be years of development contributed to it to get some business logic out of it. To get the business logic out, to develop the proofs, to make the formal verification. So yeah, trust me when I say it's tough. And ultimately, we approached this situation. We're launched into the public blockchain, or with the public blockchain. That does not mean that your search will no longer be private. It only means that all the transactions will have those aliases, same as in Bitcoin. It's pseudonyms. For now, it's going to be a public search engine. So that's how it goes. The privacy, fundamental privacy, with Zcash, with neural level, I believe that this is for post-launch. This is a challenging bit that can be handled with totally different resources at hand, different possibilities. We simply can't afford that now, at this point. Next question: when are we going to put Genesis together, Gavin style? After 7 testnets, this is that Gavin style approach. Ethereum, Polka, this is the way these people are deploying their stuff. Yeah, let's get 7 testnets rolling, and that should be enough. Cosmos is on the 9th or 10th. Somebody did 15 or 20 testnets. Well, they decided that the number should be 7. So this is the roadmap that we've put together. It's non-finite, it's not final. It's not yet finalized. Every testnet has its own objective and has its own name. There are 3 of them, 3 projects which are running simultaneously, supporting each other. I mentioned the indexer, the browser, and the chain gear, mainnet. So we are proceeding from the major objectives. The first testnet that we're going to roll out. Let me get to this. The purpose of the first testnet is called AILA. To bring some community of validators, 146 of them together initially, to bring them into a network. Then we will need to provide basic relinking, so possibly some live net is supposed to be operational to put in some knowledge graph in there. We have an app, I will show it, an app that can search in the browser by itself. But to improve usability, we need a living live knowledge graph. We need a living KG, we need a living net with live knowledge, with live data. That is the objective behind the first testnet. The second testnet, well, what are we going to have in the first testnet? Well, there will be standard capabilities, standard for I mean Cosmos, because we're proceeding from Cosmos SDK. We're going to be walking next to them, alongside. Possibly our network will be a complete replica of Cosmos, of its Cosmos counterpart. But possibly we'll also have the possibility to link. And this is the best thing. I'll elaborate on that a bit more. The first network, it calculates, its page rank is based on GPU power. So we decided to proceed from the blunt page rank, very blunt, because there were no libraries of mathematical sort to implement Spring Rank quickly. So we're going to make it happen in the next iterations. So now it's going to be weighing this page ranks and calculate it on GPUs. Next testnet, private light clients. What's a PLC? Imagine you have a private light client that you tell, please go ahead and download the part of the knowledge graph for me which is relevant to me with a depth of 2 links. Okay, so you have this 3% of knowledge out of this KG, it's relevant to you, it arrived on your PC, and then you can search offline, you can sync it with your PCs, and the main feature is you can search without relying on the global net. It will be a private search done on your computer. The local client, everything it's going to do is to synchronize the status, the state of ranks for relevance, based on relevance. Testnet 3, the objective is we want to reach the stage of a protocol, not complementation. It's my personal conviction that the thereum secret story, it wasn't just the first Turing complete, it's a success story, is because Gavin came around and wrote up a formal specification on the protocol that helped get 7 or 8 language implementations simultaneously to everyone who wanted to. It's a good thing. We're going to make it happen. The objective is to not complement Cosmos and not do substrate, but we want to make a specification for the protocol that can be worked on, that can be developed on anything, pretty much anything. And for us to succeed, we will need to make a second implementation using a different language. Possibly we'll rely on something as substrate. It's fashionable, it's fresh, it's modern. This is the objective of the third testnet, to make a multi-net. Fourth testnet, it's mandatory for us to have something on top of this knowledge graph. Various applications could be useful, so we will need some computation storage, quite primitive at least. We don't want to write it up ourselves because we've come up with a whole lot of interesting things already. Well, we will simply link on or add on something we can based on our ability. Fifth testnet is called Nash. The objective behind it, we've put it closer to the end because there's quite a lot of uncertainties about economics, about ranking. There's more questions than answers. So I would like to explain intuitively what is the logic behind our testnets. We want to collect data in an intuitive manner, to run experiments and to finalize it closer to the end. Finalize the rank and the economics. Testnet 6, winner, it will be mostly around governance and evolution, possibility to upgrade. Because like I said, it's a bad idea to launch a beast you cannot upgrade in the future. It's a bad feat. So you need to think about it in advance, how you can enhance it, how you can upgrade it, how you can contribute to its evolution. Cosmos, well, it kind of has a manual default upgrade process to it. But I like the Gavin's idea, how he upgraded the network. I believe that was the thing that is going to determine evolvability, evolution capacity of that or another computer. Because downloading it is one thing. Second question is, well, it's a whole different story when people are downloading this and the network is upgrading much easier. And the seventh final testnet will mostly be centered on security checks, on audits, on bounties, the whole shebang. Distribution prior to Genesis. It looks pretty simple. 70% will be channeled to proof of use. It's not pre-experimenting. It's not drop. It's proof of use. Well, essentially, yes, we are dropping out thereum ETH to the orders. We will figure out more ways in the future, but it's a theorem at this point. The idea is, if you fail to use the drop to mainnet, then you will only have a fraction of your potential drop in mainnet. It's mostly proof of use rather than drop. Next, 15% are allocated to, well, essentially the sources that help us develop, the coders. It's money-supported location, proof of value. And proof of code is the support with contribution in kind. I can give you some details later on. I wouldn't stop on that too much. So this was me talking about several test nets. I've talked about this already. The date would be the January the 3rd. We're going to deploy testnet 0.1 on the 3rd of January. It's supposed to be cool. So it will be a broad release. Have you tagged the browser already, Cyb? Yes, you have? Chain gear is also in mainnet. CyberD, yes, we're going to deploy it. The Genesis will be deployed closer to January the 3rd. After New Year, the hangover will be over then. So we will have the time to run the validator and get this beast out. These are the validator requirements. It's very, very agile, very fast. So what do you have there? 64 gigabytes of random access memory. You're supposed to have 64 gigabytes of RAM. Well, initially 32 can do the trick. Initially, yes, but when you pressed for RAM, you will have to build another 32. SSD, pretty big, half a terabyte, 100 megabits fiber connection, optical connection. 3 gigabytes is currently the hardcore limit that we proceeded from in a blunt manner. We'll think of smarter ways to govern it later on. Next up, you will have to get a good connection, like I said, optical connection, 100 megabits to toss this 3 gigabytes back and forth on the network as fiber. And the very cool graphics card is supposed to be there. It's not like mining. The graphics card is supposed to be powerful. This is the first consensus computer that we've built that can utilize GPU, leverage GPU calculations, not through mining, but through useful calculations. I mean, this video chip, Gleb put implementation together on the code, on PageRank calculations. So it works in a consensus computer just like that. And there's more to it. There's Golem in the Ethereum net, and you can render some files from Blender in there. But it's a bit of a different story. Rendering is different. They have a market there. They have a buyer and a seller. The seller sells and the buyer buys these calculations, these computations. In this case, the network is forming the calculations market. It's shaping demand. This has been unseen before in the industry, or by the industry. It's guaranteed and consistent demand on GPU calculations. So the red ones will not do the trick. The ATI, the green ones will be there. If you don't have the video card, a powerful one, the validator will be out of the validation process. It will simply fall short on the rank computation. So the bigger the ranks, the more video cards it's going to take. It will depend on the network evolution in the future. Yeah, there's quite a bunch available at this point, yeah, but wait for it. It's a good thing. Next, what do we suggest? Another interesting bit I would like to elaborate on in more detail. This is the concept of useful testnet. So we're used to this. A testnet is something or some story. Well, how do we perceive it ultimately before we proceed with launching any blockchain, Ethereum or otherwise? Well, it's that same Ethereum, only with one conceptual difference. All the balances will be wiped. All the SCs will be wiped. All the data will be erased before the Genesis. The only thing left will be the Genesis. And essentially, this renders all testnets. Well, I'm not referring to the testnets, Gavin. It's more of a devnet than a testnet. I'm talking about testnets prior to network deployment, when the main network is not yet around. everything that happened before is all those test nets have been useless, useful only for development purposes. We will make it useful, meaning that that kg that we're going to shape in our knowledge, it will be persistent. We will be able to take it from testnet to testnet. That means that the links that are going to be generated within these testnets, they're going to exist later on, but we'll be able to tweak something out based on the research outcomes. The balances which are going to be formed in testnets, they will need to be transferred from testnet to testnet. Rank refinement, I've talked about that. The algorithm, this is how it looks like. There are two components to it. There's a percentage of allocation per specific testnet, and there's percent of inflation that is going to be channeled to the validators of this testnet. You see that the inflation for the first one is 100% per year, and 67.45 dropping fast, reaching only 9% to mainnet. That means that initially there is an ultra incentive for validators to validate. It's 100% inflation. The second green graph, the allocation, that shows how much is allocated for a specific testnet. It's kind of a reverse logic. We want to start small because it's not yet clear how it's going to be rolling out to limit the risks. We start with 1%, 3%, 0.2, 8, 15, and then up the chain. The three final ones are going to allocate the biggest part of the distribution. The distribution of tokens will essentially run through drop. The tokens will be distributed through drop. And this is the story there. The validators will need to import the keys. And we found a way to do it safely through offline. However, it's still a kind of a thin ice to walk on. We want to give it some time. We need to give people some time, the ones who are going to import the keys. We need to give them some time to see it's all safe. So this is the proof of use algorithm. And the formula is at the bottom there. How do we calculate the genesis of every particular testnet? We take the balance from the previous testnet, we take them as is, and we combine them with the current Ethereum balances times the distribution percent in a specific testnet. That's the way it goes. So that's kind of everything I had to say. And this is a cool picture, right? You gotta admit. So I would like to thank the guys. Huge thanks to the team here. To Gleb, Artur, Valek. Thank you very much. Thank you, guys. Oля, yes, very cool graphs, very cool graphics. Nadia, thank you. Thank you for delivering our messages, helping us deliver the message. There is a presentation on IPFS, definitely. There is an appendix attached to it. It doesn't really matter. So please, any questions, fire away. I'm prepared to take them. Thank you so much, Dima. Questions, please. Dima, I got this question here. So do you have computations in floating point, in ranking algorithm? You do. How do you go around the issue that different hardware provides different computation results, different video cards? Yeah, Gleb is taken to the stage. He's prepared to answer that. If there is a clear specification, even different hardware, differing hardware components yield the same results, computation results. We use the default CUDA in NVIDIA. It supports EA standards. All the roundings, all the FMA, all the nifty bits are pretty well explained there, so that to avoid using different algorithms on different platforms, which is why we're not having issues that way. Do you have your spec listed somewhere where I can do the reading, how you compile this whole thing? Okay, perfect. I'll have a look at that on GitHub. Further questions? don't seem to be any, but hey guys, we're gonna have plenty of time for interaction. So the questions can come during lunchtime. Yes, so I made this presentation from our browser. So while you're coming up with your questions, I wanted to show you how it works. So I put in Google here, and this is the cyber app that gives me the results, the hash. The hash, the picture arrives instantly. The rank is shown instantly. Everything is working smoothly, perfectly. You can relink right here. Well, the UX is kind of sluggish, but we'll work on that. It will be instant operation. What would be the response time? 1 second validation? So essentially, you can come around and search for it. No, it's not yet recorded, but it doesn't really matter. Oh, no, there it goes, here. GOOG. It's interesting because when the users are going to clip it, all these search results, the rank will also be recalculated. All the users' activities, searching, relinking, they will contribute to this KG updating. This knowledge graph is going to be updated. And now we've zeroed it. The previous testnet that operated for a month, this mechanics was pretty cool because I ultimately decided to use it. There were applications, there were some queries which were fairly specific for our team. They were very quick to appear there. Any further questions? It's a question not to me, but to the audience. No questions? Okay, thank you guys. Thank you, Dima.